Hello, everybody. I am Ryan Fox. I'm on the developer relations team here, and today I'm joined by Tim, Francisco, and Brent from PureStake and the AlgoSigner team, and they're going to give us a nice demo of what's going on with their tool set, how to use it, and then we'll also have lots of time for questions and answers. So we're thrilled that everybody's here for our developer office hours, and I'm going to turn it over to Tim to get us started this morning. Welcome.
Hey, great. Welcome, everyone. I'm Tim Baldwin. I am a VP of Engineering at PureStake. I've been involved with the Algorand project for over 2 years, and we're excited today to talk a little bit about AlgoSigner, which is a product that we operate and develop on behalf of the foundation. So who are we? PureStake is a startup in the blockchain space. We are about 2 years old, and we're focused on providing high-quality infrastructure and development services for public blockchain networks. We've been partners with Algorand since day one. I was involved in the operations of TestNet, and the team is here for the MainNet launch. And as an organization, as a development team, we operate and have built GoalSeeker, which is a blockchain explorer, AlgoSigner, which we're here to talk about today. And we also run APIs to access the AlgoD and the Indexer API services, and we have a free tier of that that's very popular. We have a number of folks who utilize our services, and we also have paid tiers for higher throughput. Just for reference, here's some, we'll share out this deck afterwards. Here's just some of the sites that we have, PureStake.com, the developer site where we manage the APIs through, and of course the GitHub repo for AlgoSigner. And as Ryan mentioned, today on the call we have Brent, Francisco, and another member of our team, Yan, and myself, Tim Baldwin, and we're all developers on the project. I'm just going to do this is just a brief 5-minute intro, just to kind of ground everybody before we move on to a more interactive demo where we take a look at the source code, we take a look at some live sample DApps that you could work with and take examples from to build your own systems. AlgoSigner is a non-custodial Algorand wallet extension for the Chrome browser. And so what does that mean? Non-custodial is the important part. It means that we don't have your keys. The keys are yours. You load the keys into AlgoSigner using mnemonic. The keys never leave your system. The keys are encrypted and stored safely on your system, and they're never shared outside of your system. All the interaction with DApps or the ledger is done from your system out. So there's no sharing of keys. No other party has control of your keys. And from a staking perspective, that means that any rewards that accrue to the algos that you're holding are yours. There's no one to take a cut. They're just funneled back to you. With the wallet, a user you can send funds, you can opt into assets, transfer assets, and most importantly, what we're here to talk about today, you can interface with decentralized applications. And AlgoSigner is built from a grant from the foundation. It is open source. Everything that we do is available online for you. And we are regularly security audited. So we have an external firm that comes in and reviews our source code and works with us to make sure that there are no security issues. The code is well written and clean, and we have that process on a regular, ongoing basis. So why AlgoSigner for decentralized applications? So a web browser wallet is a bridge between a decentralized application and the blockchain. The keys live on the user's computer, and the users can safely sign a transaction. They never have to share any information about their private keys with the application. And conversely, the application doesn't have to know anything about the keys. So from a decentralized app, you don't have to store the keys. You don't have to keep track of the users. You don't have to make sure that the users' secrets are secure. You don't have to worry about being breached and having those secrets taken from you. Instead, you just provide a service, whatever that service might be, and rely on AlgoSigner and the user themselves to keep their information secure. And AlgoSigner is actively developed and supported by PureStake. We are continually releasing. We're on about a 1-month cadence, though here and there. And we usually we're on a TikTok release pattern where we try to do a feature release and then sort of an improvement and maintenance release. And we try to do that every month. Essentially, AlgoSigner works by the user installs AlgoSigner as an extension to Chrome. And when they visit any given web page, AlgoSigner injects a very small JavaScript library into the web page. So where the DApp is sitting over on the far left is the web page, be it a local or be it a remote application.
So basically, you have three parts. One is the background that is represented on the right with the background block. The other is the content, and then the DApp. That's basically the web page. So on the background, each of these are like separate environments running, and they don't have like a direct connection between each other. So when you run the background script, that always run, well, not always, but almost always is running on the background, as its name leads you to believe. And that's a JavaScript script that is always running on the background when you install the extension. And in this case, in AlgoSigner, that works kind of like a backend for all the things that AlgoSigner does. So you have one background running for all the tabs and windows that you have open in Chrome. There's no multiple backgrounds, no, there's only one background, and it's there as long as the Chrome is open. When you close Chrome and all these tabs on all these windows, then that's when the background script gets closed. And then there's the content script. The content scripts run for every tab that you have open. They're totally separate from each other, and they have access to the DOM or the DOM of each web page that you have open. They don't have access. They're in a separate environment from the JavaScript that's running on the web page. So the content script can't access like the environment variables or anything that it's running on the web page, and vice versa. The web page can't access what's running on the content. So what we want to allow with AlgoSigner is for the web page to communicate with the extension, so it can do all sorts of things, connecting, querying Algorand indexer, or making transactions for the user. So what we do is to let the web page, the DApp, know that AlgoSigner is installed, is that we inject a library. That's like the little rectangle there pointed. So whenever you load a web page, AlgoSigner injects a little bit of code. It's just like an API connection to every web page that you open. And then AlgoSigner library, it's available to all the web page that wants to interact with it. So that's what it's represented there on like all the connections between all of the rectangles. And the way that we communicate between all these parts of the extension is through APIs that Chrome offers to manage these communications. So between the background and the content, there's no like, the content doesn't have access to anything on the background. They have to communicate using pipes under these APIs. So that's why you see like the arrows between the content and the background using the API that is in the browser runtime. And then between the content and the injected library, there's like a connection there too. And that's a message channel port. And then the DApp can use the methods exposed by the injected library, and there are promises. So it's all like a 3-layer communication pipes between each thing that the DApp wants to do. And on the background, because that's like the backend of the extension, is where like all the heavy code is. So that's where we encrypt and decrypt your addresses and your private keys. That's where we have the Algo SDK to query and access the PureStack API and the Node-REST API. Right there, it's just the PureStack API because that's where we are using right now. We're using our own API, but it's not a modified one. It's not like a custom one. It's just the same Algorand API that you run on any node. That's what we're connecting to. And yeah, that's basically how an extension works and how it communicates between all parts of the extension. So now we can go ahead and see what all of this translates into a real world example. So we have a little sample DApp that we make just to show some basic functionality that you can do with AlgoSigner. So yeah, this is all. We show like all the methods that you can do to interact with AlgoSigner. So well, you can access this sample DApp. It's hosted on our GitHub. So you can go there and look at the code and run the live DApp and see if you are interested in a specific method or how to implement anything. You can just go there and everything is, I hope, clearly explained. So the first thing that we show here is just how to check if the AlgoSigner library has been injected in the web page. So that basically means that just checking if AlgoSigner is installed in the user's browser. So what we do on the right, we have the extract of the codes that we run on each of these clicks that we have here on the left. So basically, this is just checking if the type of AlgoSigner, that's the class that we inject, like the library. It's all accessed as AlgoSigner the method. So we just check that if AlgoSigner is defined. So if it's different than undefined, then it's installed, and we get the response on the left that it is installed. So we can go ahead and try to connect to AlgoSigner.
So the background script, like Fran said, is open as long as the Chrome, this instance of Chrome that's running on my laptop and all of its tabs is running. So I've connected previously to AlgoSigner and agreed to connect. So I can't show that to you right this second without me closing all my windows and reopening.
Well, trust us, when you try to connect, it will show a pop-up, like I don't know, MetaMask or any other kind of wallet in the crypto space would do. That it shows that in this case, like the AlgoSigner sample DApp is trying to connect, and you can allow or decline that connection. So in this case, that it returns just like an empty object. It's that we have succeeded. When the promise is successful, then it's that it connected. And if it's rejected, it's because the user plainly rejected it, or there's something else happening, a different error. But yeah. So now, when you are connected, you can go ahead and just query all the things that the library offers. So the first one is that you can query the accounts that the user has on a specific ledger. So right now we're just asking, doing AlgoSigner.account and passing ledger as a parameter. We're asking to see what our accounts are in testnet. So in this case, there's only one account, and that's what Tim is showing there. That it's the correct one. And then the other thing that we allow to the DApp is to query directly the Algorand API and Indexer API. And the way that this works, it's really simple. You have these couple of methods, AlgoSigner.algod and AlgoSigner.indexer, that is a little bit below. You just need to define what layer do you want to query, with testnet or mainnet, and what path do you want to query. And that path are the same that are that you would use to query directly the Algorand API. So the documentation that is in the Algorand developer side or the REST APIs are valid with all of these. So the parameters and the responses and everything are all the same. So here we are querying the status for testnet, and we get the response just as you would do by querying directly the Algorand API. And then if we try to do the same with Indexer, if we had a little example just to search for some assets using searching by its name. So we can just, I don't know, the name asset or something, and just have it limit to 2 or 5. That works. And that will be a successful promise, and the response of that promise would be the response that you would get from the indexer itself. So yeah, it's really easy to use, and anything that you could do with the native APIs, you can do through AlgoSigner. That includes not only doing GET requests, but you can also do deletes. You can also do puts. You have to pass additional parameters to do that, like to do the method and everything. But that's on the documentation that we have on AlgoSigner. So we can just continue and try to do a payment transaction with this. So the first couple of things that we need to do are the same that we did last time. We need to connect to AlgoSigner. We need to get the accounts to see from what account are we going to create the transaction. And here we query AlgoD to get the transaction parameters, because when you try to sign a transaction with AlgoSigner to request the user to sign a transaction that a DApp has created, it has to have all the fields that you would need on a valid Algorand transaction. That includes all the things that the AlgoD transaction parameters returns. That's the Genesis hash, the Genesis ID, last round, all like that. So you need to get that. And once we have that, we can just go ahead and try to do a transaction. So we have here a little example with all the fields that you would need to make a pay transaction. And on the right, you can see the code that is executed here. So basically, there's a method called sign. And from in there, you just need to define an object with a transaction that you need that you want the user to sign. So as you can see, it's just like a simple transaction with a prompt, with a to, with an amount, a node, all the parameters that you need to define. So we can just go ahead and try to sign that, and it will pop up the user with the request of a signing a transaction. So in this case, we also highlight if there's anything fishy about the transaction. So in this case, you can see that there's a warning above about the fee, because we didn't define if this fee for the fee for the transaction is flat, then by default it's not flat, and that's something risky. So we alert that to a user. And we do that for a couple more things where there's a closed loop transaction or anything like that. And you can see the transactions like important information right here. And if you want to see the details of the transaction, you can just go ahead, click there, and you will see basically the same JSON with all the parameters as we receive it, as AlgoSigner receive it. And once you are okay with that, you can just go ahead and sign it. With that, it will decrypt your account, get your private key, and then sign the transaction. So if a transaction has been correctly signed, it will return this object with a transaction ID and with a blob. That's almost as the SDK would return it, the JavaScript SDK. The thing about this is that if you see the blob is kind of different from the Algo SDK blob. And that is because the way that the Algo SDK returns the blob, it's on the uint8 array, so basically a byte array. And because all these communication channels between the different parts of extensions are through some pipes and some API, the only thing that you can send through them are JSON's serializable objects. And a byte array or a uint8 array is not JSON serializable. So what we do is to encode that in base 64, and that's what you get. So if you're building a DApp and wants to poke inside the transaction that has been signed, maybe to check that what you sent to AlgoSigner is what the user ended up signing, you first need to decode that in order to get the uint8 array, and then you can undo the message pack encoding, and then you have the transaction itself, and you can do whatever you want with it. But yeah, what we send is the base 64 encoded version of that. So we don't touch it, we don't modify it, it's just an encoding, and we return that to a DApp. So now if the DApp wants to send it the signed transaction, they just need, as you can see on the blob, we have a send method, and you just send us over the blob as we send it with the base 64 encoding, and then we on our side we decode it and just send it to the API. So here we just send a transaction, and we have here just a check to see if the payment transaction has been confirmed, and there it is. It's been confirmed on that round. So now if you open AlgoSigner, we should be able to see the transaction that we just sent. So there it is, a transaction from this account to this account. So yeah, and we have a little link that you can see more details of the transaction on GoSeeker. So yeah, that's the basic flow of querying AlgoSigner and AlgoD to set up a transaction and ask the user to sign it. Obviously, we support all kinds of transaction types that Algorand allows. That includes asset creation, asset transfer, key reg, all of that we allow, we support. And we can, to give you a little example of that, we can just go ahead and try to create an example, an asset. So these first steps are all the same, just getting the account, getting the parameters to send the transaction. And we have here a little piece of an asset configuration transaction. So we just need to define what we want for each of the parameters of the asset. So we set the name, the unit name, the total units of that asset, and the number of decimals that we want, and a little note for the transaction that is going to create the asset. So from here on, everything is the same for the user. We internally check that all the fields are valid. Whenever the app sends a transaction, we check that all the fields that are sent are valid. So I don't know, you can't just send a string as the amount or things like that. And we check for every transaction type, everything that needs to be there, it's there in the correct form.
Just keep in mind that so the pop-up that's shown here and the DApp in the background are in different security spaces. So they communicate over those bridges that Fran showed in the image. So the app has no idea. If we click sign and expose the key, the DApp has no access to that. That's in a different security space than the browser showing the DApp to you.
Everything's in a different like sandbox environment, and they can only communicate between the bridges. And obviously, it's not like the web page can use the bridge that the injected library uses to bypass the injected library to communicate with the content or the background. No, we check everything that it comes from the correct source and it's validated. So yeah, everything should be fairly secured, and we have been audited that everything is as secure as it can be. So here, we created the asset and we sent the transaction. So now we're just waiting for the transaction to be confirmed here. And yeah, we get like the confirmation of the round and the asset index that has been, of the asset that has been created. So there we can see the asset on the account that we are the holders of the asset. Yeah, and we don't have like the reserve address or the freeze address and clawback. We didn't define any of those in the transaction, but if you want, you can obviously do that. Opting is just the same kind of steps that you need to do to set a transaction. What changes is the transaction type. So yeah, when you want to opt in for a transaction, that basically is a transaction, an asset transfer transaction. So here we have a little bit. We query the indexer to search for an asset, so we can, in the next step, try to opt in for that asset. So here we found a decimal test asset. So once we have that, we can just go ahead and create a transaction to opt in for that asset. So we have the selectors that are all populated from the queries that we did before. And here we have the asset opt-in transaction that the user needs to sign, well, if they want to actually opt in for that asset. So yeah, well, you can see the details of what it's trying to, or the DApp is trying to make the user sign. We sign that, and the DApp gets the transaction with the block. We can just send that over. And then if we try to check for that transaction, you can see that it's there. So yeah, and if we go to now to AlgoSigner, you can see that the transaction is there for the opt-in. So this is an asset transfer for 0 to that asset. And if you open AlgoSigner, you can see that now it shows the newly updating asset as an asset that the account holds. So there it is. So yeah, that's basically it. So some basic functions and transactions that you can do using AlgoSigner. As you can see, everything is fairly simple, and it shouldn't be more. You don't need to learn anything else apart from just using the Algorand SDK and or the API on its responses and models. So yeah. So now I will leave you with Brent, so he can show you a more advanced usage of AlgoSigner.
Yep. And just to point out, that DApp is also open source, and it's just here, and you can come take a look at it. Everything's available.
All right, should be showing well. All right, so as Tim was just showing, this is the GitHub for that app or that example. And if you're in here and you're, this is all the stuff that they were just showing, but there is a transaction test, and this is going to help for different examples or sometimes more not so straightforward examples. It also will just sign the transactions by default instead of send them, so you can rapidly go through them. And here there's a sign testing HTML, and you can launch that directly with localhost. And so you can come into, like I'm using Python to launch. And when I view that in localhost on my port 9000 sign testing, I get this page. And this page is very similar kind of style to what the other was doing. If I hit on a pay transaction, it'll go behind the scenes and it'll start doing some of these things that they were clicking multiple times on, which is like connecting to AlgoSigner, verifies that connection is there, it grabs the status, it'll go through, it'll get the parameters that are currently available, it'll see if you have an account available in AlgoSigner. And so in my AlgoSigner up here, it goes and it finds the first account, which should match here. And then it'll go through and prepare a pay transaction, and it will give just like some basic data for that pay transaction in order to see. And you can sign that, and it'll go through and respond back with the transaction ID and the blob. So that's the same thing that you've already seen, and it's just logged here, which is useful. But when you're starting to get into some other things, it's a little more complicated. So like on the group transactions, you can see that we have a account here that we're signing with, which is very similar. And once we sign this one, it'll ask a second time for us to sign. And so we're taking that and we're going to combine it with the other. I'll get the code of that here in just a second. So you'll see we sign, and then we'll sign a second time. And so when we're stepping in, you know, like once we get into this group transaction, what we did was created the one transaction and then went down and created a second transaction that we're going to use. And so we're asking AlgoSigner 2 times in a row to sign. And then we're grouping them here. This is where we're grabbing the group IDs and we're casting them in the base64 so they can be passed across. And then here we're doing the await for each of the 2 signs, and we're using that information. Down here, we take the blob that we get back, we take that base64, and we're breaking it back to binary, putting it into binary arrays for the group's transactions. And then this is just a flag that says that we're logging data, and it colors it differently based on the name that I give it. So we take these 2 binary arrays and we can concatenate them into a new array. So we can grab the byte length and we create a new array of that length, and then we'll set the first half and then set the second half based on the bytes that we had from both of those signs. And those have to be tagged with that group as well when they were signed. And then from there, we can cast it back into base64, and then we can send it through using the normal methods that you would use to send the AlgoSigner send and we'll get that response. And so that's for all the group. The multi-sign is similar, but it's a little bit different in how we combine the results. And so there's a few different ways of doing that. So if we're signing here, that was the same signature as the first one, and this will actually be a different account because we're looking for multiple different accounts to sign the same thing. And so if we sign that one, you'll get a similar thing where you have the first transaction and the transaction 2 here. But in this sign, so once we start off, what we do at first is create the multiple accounts that you're going to need to sign with. So in this case, I have 3 different accounts. I've listed here the addresses and the mnemonics that you would need to put them into AlgoSigner if you were going to import accounts. And then it has the multi-sig address. It has the parameters that you would use for the MSIG. And down there's a few different ways of doing this. So the first one, I'm just asking, am I signing with AlgoSigner first, or is it the second thing? And since this was the first signature in here was an AlgoSigner signature, I can jump up to that method. And we generate the amount. We set the MSIG with the sub-SIGs that we have based on the information below. And then we grab the normal transaction information. And then we're doing that same await that we did, but we're using a different sign. So because there's a multi-sig component to it, we have to use a different sign, and this sign is going to be very similar. It's just going to be the AlgoSigner, but signed multi-sig instead of sign. And that's just so that when we receive it, we realize that it's supposed to have that MSIG component. It'll check for that, and it'll validate the transaction slightly differently. And once we get that first signature back, similar to how we did the group, we'll bring it into an array, writing out that data there. And then I build a preimage for the second account, and then decide whether we're going to use the SDK and send through to sign, or use AlgoSigner again. And in this case, you've seen that I had AlgoSigner sign that second transaction with the second account that I had. And so we stepped in here and we waited for that second signature, also got the binary from that, and then we did a merge of those 2 multi-signature signs together. And once they were merged, then we were able to return that data back down to our base function, which sends the result on as normal. So it just uses the AlgoSigner send, and then took that data after it's sent, and then just displays the data in the send is only if we have this in the transaction. So this is prior to that. We skipped this step at the end because we didn't have the send signed transaction as true. But we can see that we've broken out that data into a more readable format just to verify that the addresses are correct. That uses a internal method here that just recursively goes through and casts the JSON into either addresses, or it'll try to bring it into an ASCII format. If it's an object, it'll just go deeper, continue to go through and give us all that information. And so if we wanted to click one of these and actually send through, it'll be the very same thing, only it will actually submit that, and you'll get a transaction ID from that as well. So it's just an easier way to see several different types of transactions, and without having to send the transaction, you can verify, even if you don't have, say you wanted to do a transfer and you didn't have a asset, I can go ahead and make that transfer even though I don't own the asset that is there, because none of these accounts currently have assets. But it's only because I'm not sending it through. So it's just a useful tool.
Yeah, we actually built this tool as part of our own testing to make it very clear what was happening, and then we thought we would just include it, so that everybody could take a look. Because for each of the scenarios that you saw, we ended up writing, different kinds of tooling to be able to evaluate it and test it automatically. And I'm just going to wrap up. Just wanted to show you some quick resources here that you can access. So this is the repository for AlgoSigner. It's all open source. And we keep track of the different releases. If you're interested in the code of AlgoSigner, it's always here. You can download it, build it yourself, and load it into your own browser. And we have instructions for that if you don't want to get it from the Chrome store. We also keep here, so there's links to the 2 different kinds of the tests that we have and an integration guide for what are all the methods that are exposed by AlgoSigner, any rules around, for instance, what kinds of, especially this is for signing transactions, what kinds of things need to happen, places where it needs to be 64 encoded, and things like the new multi-sign functionality discussed here. And lastly, in the library, the other thing that's interesting, we do have a fairly comprehensive set of end-to-end tests. So there's end-to-end tests that show DApps, app. So this exercise is if you're working with the DApp, you can actually, through AlgoSigner, you can send in, you can create an application and work with it. And so this will walk through and show you all the different things that happen to do that, so that you have an example and you can see it live and working, so that you can verify, what we're doing and what you're doing. We also have basic, a set of ETE tests for things the UI is working, that all the different DApp functionality that we showed you is working. Just a few things coming up in our roadmap. So like I said, we're on a constant release cadence. So we have 2 kind of things in flight. One is custom networks, the ability for you to add in. So today, MainNet and TestNet are hard-coded in, and the API that they use is defined in the script. We're going to add in the functionality for you to add your own local dev network, or for instance, to add in BetaNet, which we have API support for, but we aren't supporting directly in AlgoSigner yet. And so that's work that's kind of underway. And we have 2 different efforts around the JS SDK. To give you a little perspective, the JS SDK v2 did not exist when this project kicked off and did not come kind of into place until June, July last summer, right before sort of the first AlgoSigner release. And now that the JS SDK v2 has been around for a while, we're looking at some different ways to more closely integrate the 2 projects so that it's more seamless. If you're going to use the JS SDK and you want to use AlgoSigner, or you intend that AlgoSigner be a signing tool, that interaction is not as cumbersome. So today you're defining and declaring sort of objects on your own, and you don't need necessarily the JS SDK. But if you're using the JS SDK, we want to make it very easy for you to use AlgoSigner. And lastly, we're also looking at ledger support. So we know that a lot of folks really like the Ledger hardware device, feel it's very secure, and so we're going to be figuring out how we integrate the Ledger device with AlgoSigner. Just will include this deck. There's just a few places. I am often found on the Algorand forum. I answer questions there. I'm also active on the Algorand Discord, and I answer questions there specific to both AlgoSigner, the API services, but really just any questions except for Java questions. I leave that to Mr. Jason Weathersby and Fabrice. I skip those, but everything else I try to help out there. And I think that is the main of what we had to show today.
Great, thanks, Tim. Thanks everybody from the PureStake team and the AlgoSigner team here. Tim, Francisco, Brent, really appreciate your time here. Katie as well, behind the scenes answering questions for us all here today.